In a recent fMRI study published in Cerebral Cortex, researchers found that when people viewed images of someone they deeply loved, their ventral tegmental area, VTA, and caudate nucleus lit up in the same way we see reward-related brain circuits respond to money, food, or addictive substances. What if I told you your brain is wired to be charmed, not just by appearance or charm, but by intricate neural and hormonal signals you can't even see? Today, we'll uncover how the brain becomes charmed by a woman, step by step, scientifically. Step 1. First perception and sensory input. The journey begins with sensory signals your brain can't ignore, visual cues like facial symmetry, expressions, gaze direction. The brain rapidly processes faces in visual cortex and fusiform face area, which feed into social brain circuits. At the same time, auditory cues, the sound of a voice, pitch, tone, cadence, can strongly influence attraction. Even olfactory cues, subtle body odor, pheromones, even natural scent play roles in unconscious attraction, though human pheromone research remains contested. Nonverbal signals also, posture, body language, and mirroring, when two people unconsciously mimic each other, reinforce rapport and signal compatibility. These cues feed into attention systems in your brain, preparing the ground for something to become meaningful. Step 2. Attention, novelty, and reward circuit activation. The brain favors what is novel, surprising, or emotionally salient. When something breaks from the expected, perhaps a distinctive laugh, a unique gesture, your brain's attention systems turn toward it. Once that initial switch happens, focused attention locks in. Your brain zeroes in on the person, filtering out distractions. This is where the magic intensifies. Key brain regions, VTA, nucleus accumbens, ventral striatum, parts of the caudate, are engaged, the same ones involved in reward, motivation, and pleasure. Step 3. Emotional arousal and physiological response. With reward circuits active, your body responds. Heart rate speeds, palms sweat, breathing deepens, your gut butterflies churn. Adrenaline, norepinephrine, and other neurochemicals flood your body. As attraction deepens, release of oxytocin begins, especially during closeness or physical touch. Step 4. Cognitive and psychological investment. Your mind becomes invested. You begin fantasizing, daydreaming, replaying interactions. You selectively filter, overlooking faults, magnifying strengths. You build an internal love map, unconscious expectations about the ideal partner, and start evaluating her through that lens. Step 5. Attachment and long-term bonding. Attraction can evolve into deeper attachment. Over time, oxytocin and vasopressin become more central, supporting trust, intimacy, and pair bonding. Neural changes also occur. The prefrontal cortex begins reigning in impulsivity, helping regulate emotions, conflicts, and realistic evaluation of partner. In long-term love studies, for example by Bianca Acevedo, even after years, partners still show activation in reward circuits, though modulated by attachment circuits. Step 6. Conflict, rejection, and brain response. When attraction isn't reciprocated or conflict arises, the brain doesn't simply shut off. Areas associated with pain and craving, such as the anterior cingulate cortex, get involved. Heartbreak feels physically painful. The reward system can stay engaged, leading to rumination, longing, even addiction-like behavior. Thus, The same circuits that made you fall in can keep you trapped in emotional loops. Step 7. Evolutionary perspectives. Why does all this exist? From an evolutionary lens, these mechanisms promote mate selection and reproduction. The brain rewards cues of fertility, health, resource potential, and compatibility. Yet there's a trade-off. High reward comes with risk of obsession, rejection, or misjudging compatibility. Step 8. Individual differences. Not everyone gets charmed the same way. Personality traits, for example, openness, attachment style, past experiences, trauma, previous relationships, cultural norms, all shape how strongly you respond. Some people fall quickly, others slowly. Some idealize deeply, others remain more cautious. Brain-wise, studies show that direct modulation of activity in medial prefrontal cortex, MPFC, can alter perceived attractiveness. Increasing activity can reduce attractiveness, and decreasing it can boost attractiveness in tasks. This suggests that internal brain states influence how charmed we become. Step 9. Implications and takeaways. Knowing how your brain works gives power and balance. You become more self-aware, understanding when attraction is genuine connection versus superficial infatuation. You learn to manage expectations, guard against obsessive thinking, and foster deeper connection rather than mere surface fascination. You can channel this knowledge to build healthier relationships, more sustainable romances, and greater emotional intelligence. It's not magic. It's biology, psychology, and growth combined. If you enjoyed this deep dive and want to see how you can use this knowledge in your daily relationships, hit the like button and subscribe.